Hello, my name is Rich Howard, owner of Architectural Builder Supply, and on this project we're creating some cutouts in push plates for a client. And this project is 2 hollow metal doors that we're supplying that is going to the National Park Service out in Colorado in the general Lake Tahoe area. And there are, in national parks, there are very often restroom facilities, and those always have, typically I've always seen them with hollow metal doors, whether it be a rest stop on a highway or a National Park Service. These public accessible places typically have hollow metal. And I'm not sure exactly where around the Lake Tahoe area it is. I know it's the southern part of Lake Tahoe, but there's obviously some sort of a public access. Boat launch, campground, forest, park, state park, national park, whatever it is. A couple of bathroom doors that need to be replaced. They're very likely 15 or 20 years old, and they're just typical 18 gauge cold rolled steel, and I'm actually surprised they lasted that long. Doors that are going to be used in that application really need to be 16 gauge seamless construction. Probably polyurethane would be my guess, only because it has a very good R value, which may or may not specifically matter, but it's a really great dense core as well. A Seco medallion might be an option to consider as well. You know, if I'm going to drop a name. Back in the old days, if it was Kiwani, for me it'd be a D416. That would be a seamless beveled edge hollow metal door with really heavy reinforcements for hinges and whatnot. And speaking of that, when you've got a door like that, yeah, you're going to be wanting heavyweight hinges, 5-inch tall, even if it's a 3.0 door. And it may not be an awful idea to have a continuous geared aluminum hinge. It's taxpayer money, but at the end of the day, I think the taxpayer wants to invest into something that they're not going to replace prematurely. So anyway, this job is 2 hollow metal doors. The bathroom doors have single-cylinder deadbolts, just regular garden variety, residential caliber single-cylinder deadbolts. They've got push plates on both sides that have a set of back-to-back pull handles on both sides. So to pull the door open, you'll pull the door open. To enter the restroom and close the door, you'll be physically pulling the door closed and throwing the deadbolt. So each of my plates, of which there are 4 because we have 2 doors, plate on the inside, plate on the outside, I'm going to have a 2 1/8 inch hole for the deadbolt on both sides near the top. Then I'm going to have 2 holes for the through bolts for the push and pull plates. And while we're going to go through making the tool pathing in VCarve Pro, part of this video is to also think critically about what actually makes sense in terms of having a nicer installation for the material, in terms of where the hardware is positioned. So let's switch to the screen view and I'll show you what we are matching for the client. Okay, and before we get to looking at the hardware, let's just look at the images that the client has sent me. They reached out to us because the door is an Amweld door, and we were Amweld distributors when Amweld was still a company in business. Maybe about 2008, that was a storm that cleared out a lot of weak trees, that's for sure. Amweld was one of the victims of that 2008 era. The label that's on the door, admittedly, a lot of people will call and say, yeah, okay, I've got this, they'll give this number here. Yeah, I need an ASTM E152. How quickly can I get it? Well, none of this tells me what the door is. This is important. This is actually a fire label. It tells me that this door has a fire label on it. Doesn't mean it's fire rated. And when you have this information, this is also really important. If you have pairs of doors, you can end up seeing this as 3/4 inch minimum latch throw, so be really mindful of that. That's the middle hinge location. 30, that tells me it's Amweld. That's the 3rd hinge location, that's Amweld. That's the overall height of the door, that's good. Giving me the dimension for the lock preparations from the top down. I'm assuming he's got that hooked on the top of the door. About 34 13/16. The client wants nothing here. So there won't be a lock prep. Top hinge location. and then the width of the door. All that's good. Now, also what I had said to the client is, listen, you're going to want, the client only wanted the two doors, and I, without intending to upsell, I sold him on the hardware because reusing this is going to be dreadful. These screws are beyond rusted in place. These hinges are plain bearing. Now, what's really interesting is this is the third hinge, the bottom hinge. That's the middle hinge. That's the top hinge. Take note of something. Bottom hinge. Take note of the margin between the barrels here. Looks reasonably tight. Reasonably. Let's look at the middle hinge. Okay, still looks reasonably tight. Let's go to the top hinge. No longer reasonably tight. That's because the top hinge carries 70% of the weight of the door. So these are not only zinc dichromate plain bearing hinges, but just the wrong hinge altogether. I'm not sure why they're replacing this, but a poorly specified hanging device will certainly contribute to a premature failure. So, I said to the client, listen, hinges are really inexpensive, and they're really the most important part of the opening. What I said was I would use a penetrating oil, however you can possible, even WD-40 that you can direct on here and let that soak. Maybe put a number 3 Phillips in here and give that a little bit of a whack with your hammer to try to break the rust loose. Try to get those out. If you can't, you'll have to drill them out. Use a screw extractor at the same time. And that's exactly why he didn't want to replace the hinges, because he knew he would have to drill the hinge screws out, or assumes he'll have to drill the hinge screws out, and didn't want to do it on both sides. I says, well, if you do that, you've got a severely worn hinge, and you're still going to need machine screws. And those things are $1 each, so why not just get the hinge? Well, they're not $1 each, but they're cheap. So I wouldn't say reluctantly, but he agreed to the logic of, yeah, give me hinges. Now, the lock prep, as I had mentioned earlier, there's just going to be a garden variety single-cylinder deadbolt that's going to be installed. Now, let's take a look at the push-pull hardware of what they want to match. And before we get there, keep in mind, about 34 and 13/16, roughly 34 3/4. Let's keep that in mind.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
Okay, this is what the client wants to match. Unfortunately, I have only these really low resolution images here. If I'm guessing, it's probably a 6-inch, maybe an 8-inch center to center. We're going to go with just something really garden variety here. Maybe 3.5 by 15. I'm going to go with a larger plate, like a 6 by 16. That's the outside, obviously. That's the inside. That's what they're going for. Okay, this is a different facility, maybe just a different restroom at a different part of the park or some other park. Who knows? I believe this is an old B160 deadbolt because that thumb turn looks like it's the old B160, a deadbolt that they discontinued many years ago. The B460 was their grade 1 version. That's a nice deadbolt as well. What I like about the B160 is it'll fit into a 1.5-inch hole. And I've ordered for the client, I'll have to look up the order, and we're going to go with the smallest diameter hole possible on the plates. I don't remember if it's a B60 that I ordered. I think it's a B60. We'll look that up. Now, what I'm driving at in terms of installing this, he's got a back set here. Well, back set from the edge of the door to the center of the hole. It's 2 3/4 most likely. Let's just assume it is. On the inside, it's going to have the same back set. The issue, however, is we're not going to go with the deadbolt mounted right in the center of this. It'll have to be biased to one side. But we're also going to need to account for the stop that's in the stop projection. And we're going to study that. And what I'm referring to is, just do it here quickly. Let's assume that those doors swing out. And if our center line is going to be 2 3/4 over, and if I put my plate, if I consider my offset of my plate, let's say a 1/4 inch, I'm going to want my plate to be a 1/4 inch off the edge. If I try that trick over here, the plate's going to come between the face of the stop, and the inside face of the door, so I don't want that. So what I'm going to do is give the client a prep in the plate at 2 3/4 from the edge of the door, but 2 3/4 less what reveal I will leave here, and then adjust this plate accordingly so that this is all in the same location. So what I'll end up doing is taking this dimension, and it'll be x minus a 1/2 inch is what it'll probably end up being. Meaning this is 5/8, that's 1/8 of an inch. So if I'm going to adjust it by a 1/2 inch, I'll adjust it by a 1/2 inch. The plates won't be mounted at the same backside on the door, but the bottom line is they'll be adjusted to account for the fact that here's the plane that I need to be worried about on the pull side, and here's the plane I need to be worried about on the push side. So it'll look odd, but the client will quickly figure that out. And what I'll do is mark on the back side of the plates, outside plate left hand, outside plate right hand. So we're going to have 2 hands of each outside exteriors and 2 hands of each interiors is what we're going to have. And we're going to use VCarve Pro to make sense of all of that. So let's move on to VCarve Pro. Okay, let's dive into VCarve, and I hope I don't regret doing it here. I don't like the dimensioning here as much as in AutoCAD. So create a new file. Awesome. Our aluminum is 50 thousandths thick, and we'll get into this a little bit and then we'll figure out what we're doing. So, it's always about the fixturing with this stuff. It's always about the fixturing. Maybe what I'll do is I can either screw them all down, just using drywall screws, frankly, to hold it all down into the spoil board, or just clamp it down. Maybe what I'll do, since there's only 4, and I don't expect to do it again, I think I'll just do them as single pieces. Let's just draw one. So the plate is 6 by 16, if I recall. So that's what our plate actually looks like. And we're just going to zero to the outside corner of the plate. And we'll call this the top, and we'll call this the bottom here. So single-sided, 6 by 16. I believe they're 6 by 16. We'll take a look at what hardware we're drilling into. We will Z0 off the material surface. I'll Z to the top. Just to be fun about it. Silver satin. Okay. And that'll show up in our 3D view when we do this. So this can be the top of the plate. We'll just reference this to the top of the plate. So the question really becomes is how far down do we want the deadbolt prep to be? And if you recall, I had indicated, keep in mind that 34 and 13/16, top of the door to the center of that. So if we were to go to the center of the plate right at 8 inches, 34 plus 8 is going to be 42 and 13. So that's pretty good actually for the center line of a pull handle. But what we'll do is let's go down to what would be 9 inch from the top, and that would be 43 and 9/16. I like that for a center line because that's the center line of a lock. So we're going to use that to balance our pull handles over, meaning I've got to drill some 3/8 holes in here for the pull handles. So the first thing is to give us a idea of where to put the deadbolt. But before we do that, let's figure out what deadbolt I'm using. Let's take a look. Off screen I will pull up what I did for the deadbolt, and then we'll see if we can find installation instructions for it. Yeah, okay, so I ordered for the client a couple of Schlage B60s. So let's bring in a browser window. Because if this will go to 1.5 inches, I'd like to use 1.5 inches. Okay, I think it maybe will. I'm looking for a PDF document. This may be it. B60? We're doing a B60? Okay, B60. Great. Yeah, 2 1/8 or 1.5 inches. I like 1.5 inches. I want to remove the least amount of hardware as possible. However, the problem is I told the factory 2 1/8. I know that I did. And I ordered the doors before I knew what deadbolt I was doing. So I can either contact the factory and tell them to change that, which is going to be a lot more work than it's worth, or just go with 2 1/8. We're going to go with 2 1/8. It's not the end of the world. Next time I do this, I will definitely think about that a little bit better. We were going to use a B600 series deadbolt by Schlage of the heavy duty. It's just the client couldn't justify the cost. So here we are, 2 1/8. So we know that it's a 2 1/8. Let's take that browser window and keep it alive. Now, you might say to yourself, well, what about the added thickness of the push plates? And yeah, that is a concern, because they don't tell us the maximum door thickness permissible for this. 1 7/8, well, I mean, assuming that Skynet is accurate, 1 7/8, which is typical. So our door is 1.75 plus 0.1, 1.85, and 1 7/8 is 1.875. So we're good. We're in good shape with our door thickness. So then it becomes, where will we place the deadbolt? So what I want to know is, if I'm going to balance off of where this pull handle is, I want to know the center to center. And I happen to know that I'm using the Rockwood 105 and a 630. I have those back-to-back pull handles in stock, and these are 5.5 inch center to center is what they are. Yep, 5.5 inch center to center. Okay, that's good. So let's do this. Let's bring ourselves a new guideline relative to this at 5.5 times 0.5. Oh, I thought it would calculate right in there. So we want to create a new guide that's 5.5 inch. And while, yeah, you can obviously do 5.5 divided by 2 in your head at 2 3/4, I do the basic math with a calculator. So I've got one guideline that's relative, 2.5 above. Now I'm going to put one below, negative. There it is. So this is going to be where our pull handle will center. That'll be fine. Now the question becomes, is where do we put our deadbolt? We got to have a 2 1/8 inch hole, and this dimension is 6 1/4. Let's see what 2 inch down is going to look like. Let's go 1.5 inches down. Now the question becomes, is what backset will we put this at? So let's just think about the outside plates first. If we're dealing with a right-hand reverse, which will have one of each, we'll say that we'll have a 1/4 inch backset off the edge of the door. Actually, we're going to go with 1 inch. And the reason is, in the edge of a hollow metal door, there's going to be reinforcements. I don't want the client to have to struggle getting a tiny little screw into lots of steel. So we're going to hold it back, that plate 1 inch, so that his screw will hit just the skin of the door. So we're going to hold it back 1 inch.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
I grab a guideline. I'm going to go in 1 inch. And it's just a visual indicator. Right mouse button, current position 1 inch. Okay, great. Now, I want my deadbolt at 2 3/4 backset, even though it can be 2 3/8 as well. No, 2 3/4 would be better, because these are 6 inch wide plates. So let's create a new guideline relative at 1.75. Create. Now, this guideline should be 2 3/4 from the edge. So let's measure. Yeah, 2 3/4. You can see it in the upper left-hand corner. I'm at 2.75. So that's good. So now we know that this is where our center of our 2 1/8 inch hole is going to be. Actually, let's rethink that. 1 inch. Let's get rid of that. Let's do this. Let's bring that down to 1 inch. Down. Let's create a new guideline relative 1.0625. 1.0625. The issue is I don't know the outside diameter of the deadbolt. So what I'll do is I'll add a 1/2 inch for that. Relative 1.5625. Create. It's not creating it. This needs to be negative. Create new guide. Okay. So that should be the center line of our 2 1/8 inch hole. This is going to need to be at 2 3/4 and 13 7/16. 2 3/4 and 13 7/16 with a 2 1/8 inch diameter. Create. Not awful. Actually, something's not right here. Close. Material setup. Oh, okay. I must have had that on radius. Yeah. Apply. There we go. Much better. Okay. So that's nice. That deadbolt's going to fit in here reasonably well. Then we're going to need a hole for the push plate right here, wherever this is, at 2 3/4 and 9 3/4, 9.75. And that diameter is going to be 3/8 because the bolts are going to be 1/4 inch, 1/4 20, and I'll have a 3/8 hole there for those bolts. Create, I like that a lot. Then we're going to do 9 3/4 plus 5.5 is going to be at 15 1/4. Maybe a little close. Create. Oh yeah, no, I was going the wrong way. I need to be at 9 3/4 minus 5.5 is 4 1/4 on the y-axis. Create. There we go. Now you'll notice I've got a circle up here I don't need. So that'll be the center to center for my pull handles, and I think that's okay. I could drop them down a little bit, or use a larger center to center pull handle, but I've got the 5.5 in stock. So now we've got this all drawn out, and we're going to call this the outside. And then what we're going to end up doing is, for the inside plate, is we're just going to deduct that additional margin for the stop. Okay, now what we're going to do is we're going to take these vectors and we're going to move them to a layer. But what we'll do is let's rename this layer EXTRHR. Great. Now what we'll do is let's grab these, and the guidelines don't matter. So let's grab our vectors. We're going to copy to a new layer, and we're going to call it EXTLHR, so the exterior of the left-hand reverse. Okay, now up here, we can turn our layers on and off. Well, you can't see that, unfortunately. Let me pull that down. Yeah, so I've turned off my RHR layer, and I only have my LHR layer on. Now the purpose of all of this is I want to take all of this, and I want to mirror it. Flip about job center should work, and we want to flip horizontally. Yeah. So what that should have done is now given us this margin on the left-hand reverse side that we had the same as on the right-hand side. So these are both of the layers shown at once. Both the layers are on. I've turned off the right-hand reverse layer. And what we'll do is let's do a little bit of just comfort, I suppose. Edge of the plate to the edge of our 2 1/8 inch hole is 1.66 inch. Okay, let's turn on our left-hand reverse and go from edge of plate to the edge of the hole, 1.67. So we have flipped it around its vertical center line and easily gotten us the exterior of the left-hand reverse and the right-hand reverse. Okay, so let's do this. I should have done this immediately. Save as Lake Tahoe push plates. Let's save that. Now, let's go back to the camera view and let me show you the actual hardware that we're using.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.